In this video, we'll move on and talk about projections for future population growth. There are three things that I want you to get out of this video. First, I want you to be able to explain the variables that are used to project future human populations. Here's a hint on that one. Those variables are the same demographic factors that we've been talking about in prior videos. Second, we're going to start the exploration of quantitative models. We're not going to get very deep into this topic in the video, but by the end of this, you should have a sense and an ability to articulate the differences between future population projections based on a basic sense for how different models generate different future estimates. Last, I'm going to show you some recent research results from a paper that came out in July 2020 that actually shows the human population will start declining around 2064 for reasons that should make some sense for you if you've been watching prior videos. First, a quick overview of how you actually project forward to estimate future populations. This is a type of approach that we're going to come back to over and over again in this course, not just for population growth, but for any projection of future environmental change. These projections are almost always carried out with models, and we'll talk more about models in coming weeks, but a model is simply a conceptual or a quantitative representation of reality. For population growth, we can simply fit mathematical models of historical growth and project those trends into the future. Or alternatively, we can dig deeper into some of the changes in demographics that are underway around the world and then use those to model future populations in more complex ways. I'll give you a couple of examples of this in the next few slides. Let's start with the official United Nations population estimate. This estimate is updated annually, and it's typically used as the best guess for where global population is going. It would be challenging to explain the entire UN approach here, but in a general sense, the projections use a mix of statistical models and projections of changes in variables such as total fertility rate to estimate future population country by country. The UN also assumes an uncertainty of about plus or minus 0.5 children in the total fertility rate in the future, and this is used to provide a range of projections as shown in the figure. The best guess for UN projections is about between 9 and 10.7 billion people by 2050 and 9.7 to 13 billion people by 2100, with a midpoint in those projections, so best guess or a middle estimate of 9.7 billion in 2050 and 10.8 billion in 2100. Big ranges. As you can see in the graph, all but one of these projections show a leveling off of growth, but the range in estimates come from variation in estimates of how quickly the underlying factors like total fertility rate will decline into the future. And all the projections, with the exception of one or two, show pretty large increases in population to 2100. To understand a little bit more about why it's such a challenge to predict future populations, let's take a look at China. I picked China for this example because the population curve for China between 1950 and the present is really quite interesting. Take a look at this line and think about the patterns that you see. Is it going up? Is it going down? Does that change over time? How would you approach projections of growth for China? We need some kind of model to make these projections, and that model needs to have assumptions that can be used to project future change. This might include assumptions about fertility, as we've talked about. We might try to anticipate future policy changes, although of course that's very difficult. But one way or the other, we need to make assumptions about the trends that are going to affect population growth. Or we could just assume that population growth will continue as it has in the past. The simplest approach to analyzing this growth curve would be to assume that the future will be like the past. And we get that if we fit a straight line to the last 70 years of data. Remember the equation for a line. It's y equals mx plus b, where y is a population at time t plus 1, so 1 year in the future in this case. X is a population at time t. M is the slope of the line, and so it has units that represent the y-axis divided by the x-axis. And so in this case, that would be billions of people, y-axis, per year, x-axis. B is the intercept, which is the y value when x is equal to 0. The most interesting number from this line is the slope, which tells us that 13.8 million people were added to China's population each year on average between 1950 and 2020. If we take that number and we multiply it by 80, which would be the difference between 2100 and 2020, then we would estimate that China would add another 1.1 billion people in the next 80 years. The question you have to ask yourself here is whether the straight line is a good representation of the data. And the answer, if you look at this graph, is no. From 1950 to somewhere in the 1970s, the straight line actually looks like it underestimated growth. And then in the period from 2000 to the present, the straight line looks like it overestimates growth. There's a lot more going on in the population of growth of China than we can capture with this simple linear fit. Here's an example of an alternative model. In this case, I fit a curve to the data from 1950 to 1980, and then I projected that curve out to 2020. That's the blue line. I also fit a curve from the data from 1980 to 2020 and projected that one back in time to 1950. These two curves give us very different perspectives on the timing of China's population growth. I picked 1980 as the point to try different fits because this is when China instituted the one-child policy, which restricted couples to a single child specifically to reduce the rate of population growth. One way to interpret the blue line here is as an estimate of what China's population might have been if the growth rates from 1950s and 60s had continued into to 2020. What is clear from these curves is that the growth rate in population for China has slowed dramatically in the last few decades. And in fact, China recently relaxed the one-child policy out of concern that an aging population could undercut economic development. In the data exercises, you'll have a chance to work with population data yourself and try different ways of fitting simple mathematical curves to data on population for different countries. Now, it should be clear at this point that it's very difficult to predict future population growth. A very interesting paper was published in July of 2020 in The Lancet, a prestigious medical journal. This paper used a very sophisticated model to provide an alternative projection of future global population growth, and their findings are very interesting. They predict, based on their modeling, that world population will peak in 2064 at about 9.73 billion, before declining to 8.79 billion by 2100. I've made this paper available for you online if you want to take a closer look. And I copied the interpretation of the authors here because it's so interesting and relevant to what we've been discussing in these videos. You can read the statement yourself, but the key argument is that falling total fertility rates will result in population declines in many countries, and actually for the entire planet by the end of this century. The paper notes that a combination of enhanced female reproductive health and services plus increasing educational opportunities for women in many countries around the world are resulting in lower rates of population growth than what the UN has estimated in recent reports. There's much more in this paper, including estimates of which countries will likely have the strongest economies based on analysis of population demographics for 2050 and 2100. Have a look for yourself and see what you think. One more slide in this video, and this is a familiar one. You saw this United Nations age pyramid for Western Europe in an earlier video. The implications of global declines in population are very interesting and important. As we'll talk about in the next video, these declines would likely reduce global environmental impacts. However, these changes would also create economic challenges because of the declines in working age populations and the rise in other age populations like the elderly. Think about who pays for pensions or Social Security in the United States. It's the people in the current workforce that are paying for current retirees. If there are more retirees than there are workers, then these systems will face big challenges. To wrap up, it's important to remember that these population projections are uncertain. At best, we know that world populations will likely reach somewhere around 9.5 billion around 2050. After that, there's a lot of uncertainty. We could go up or we could go down. In this video, you've had a first introduction to the use of models, and models are incredibly important in environmental science, but they always have limits and they always have uncertainty. Understanding both the limits and the uncertainty is really critical for anyone working in this field. Lastly, and this should sound familiar, demographic factors are changing in ways that will reduce population growth rates, and specifically changes in female access to education and family planning resources may or are likely to lead to declines in populations in the coming decades.